Continuing on with Chapter 3, we are going to learn two new skills. And those skills are to learn how to calculate molecular/formula weight and to learn how to calculate mass percent/percent composition. So let's jump right in. First, we're going to take a look at how to calculate molecular/formula weight. Now, the reason why I have a slash between the words molecular and formula is because for the purposes of this course, both words mean the same exact thing. So regardless if someone says molecular weight or if they say formula weight, they're talking about the same exact thing. Now, the molecular weight is the sum of atomic weights of the atoms in a molecule. And this number is expressed in AMU. So that's the unit that we use. Now, when I say the sum of the weights of the atoms, what I'm talking about are these numbers that are underneath the elements in the periodic table. So if you notice, there's these numbers down here, and these numbers are what's called the element's atomic mass. So for example, the atomic mass of carbon is 12.0107. The atomic mass of nitrogen is 14.0067, and so on and so forth. Now these numbers are kind of long, so the general practice is to round them to 2 decimal places. So for example, for carbon, we use 12.01. For nitrogen, we use 14.01. For oxygen, we use 16.00. So we're just taking in these numbers and we're rounding them so that they have 2 decimal places. So again, the numbers that are underneath the elements here are called that element's atomic mass. Now, how we figure out the molecular weight of something is we take the number of elements we have in the molecule and we times it by the mass of that individual element. And then we just add that together for however many elements we have. So let's look at an example because I think it'll make a little bit more sense to you guys. So let's say we have a molecule of ethane, which is C2H2. Now, we want to figure out how much does this molecule of ethane weigh. And to figure that out, we figure out the molecular weight. Now what we do is we take a look at each element individually and we add them together. So let's look at carbon first. How many carbons do I have? I have 2 carbons, so I write down a 2. Now I'm going to multiply that by the atomic mass of carbon. So if we look up here at our periodic table, we'll see that the atomic mass of carbon is 12.01. So I'm going to multiply that 2 by 12.01. Now I'm going to get the same information for hydrogen. So how many hydrogens do we have here? We have 2. So I take 2 and I'm going to multiply it by the atomic mass of hydrogen. So if we look up at our periodic table, the atomic mass of hydrogen rounded to 2 decimal places is going to be 1.01. So that's what we're going to use for right here. Now, punch this number into your calculator, and you should get 26.04. Now, don't forget about AMU. That's the unit for molecular weight. So that is how we figure out the molecular weight for ethane. Now let's do another example just so you guys get some more practice. And let's try to figure out the molecular weight for water. Now, we're just going to follow the same procedure. Starting with hydrogen, how many hydrogen atoms do we have? We have 2. We're going to times that by the molecular weight, the atomic mass of hydrogen. So if we go up to our periodic table, the atomic mass of hydrogen is 1.01. So we'll write that down here, 1.01. And we're going to add that to oxygen. How many oxygen atoms do I have? Just 1. Times the atomic mass of oxygen. So if we go up to the periodic table and we find oxygen, and we round that number to 2 decimal places, it's going to be 16.00. So I'm going to put 16.00 here. Now punch this into your calculators, and you should get 18.02 AMU. U. So that's it. That's how you figure out the molecular / formula weight of any molecule. Now this is a skill that we're going to have to use in order to determine percent composition / mass percent. Now again, the reason why I have a slash here between these two terms is because they mean the same exact thing. So whether a question is asking you to find percent composition of some element or mass percent of some element, it's asking you to find the same exact thing. So percent composition is a little more specific. So what percent composition is, it's finding out how much of each element makes up the whole thing. So let's look at ethane again, our example from above, and we figured out that the molecular weight for ethane was 26.04. Okay, so that is the molecular weight of the entire molecule of ethane. So percent composition applies to each individual element in a molecule. So we need to find out what percent of this ethane molecule is carbon and what percent of this ethane molecule is hydrogen. And we do that by using this formula above. So the formula is mass percent is equal to the number of atoms times the atomic mass of that element divided by the molecular weight of the entire molecule. So let's do an example using ethane, and I think it'll make a little bit more sense. So we already know that the molecular weight of this entire molecule of ethane is 26.04. Now that number is what's going in our denominator. That is the molecular weight of the whole. So now we want to find out what percentage of this 26.04 is carbon. So we do percent carbon is equal to, how many carbon atoms do we have? Well, we have 2. 2 times the molecular weight of carbon. Now if we go back up to our periodic table and we look at carbon, we see the molecular weight of carbon is 12.01. So we're going to put 12.01 right here. And now we're going to divide this number by the weight of the entire ethane molecule, which is 26.04. And we're going to times this number by 100% because remember we're figuring out a percentage. So if you punch that into your calculator, you should come up with 92%. So now what that's telling us is that 92% of this ethane molecule is actually carbon. So now let's figure out what percent of the ethane molecule is hydrogen. So we're going to go through the same process. First we do how many atoms of hydrogen do we have? We have 2. We're going to multiply that by the atomic mass of hydrogen. So if we go back to our periodic table, we look at hydrogen, and the atomic mass is going to be 1.01. So 2 times 1.01, and we're going to divide that by the mass of the entire ethane molecule, which is 26.04, and we're going to times that by 100. Now if you put this into your calculator, you should get 8%. So now that's telling us in any ethane molecule, C2H2, 92% of that molecule is made up of carbon, and only 8% of that molecule is made up of hydrogen. So let's do one more example for some extra practice. Say I have this molecule here, C12, H22O11. Now the first step in any mass percent problem is to find out what is the molecular weight of the whole molecule. Now, do you remember how to do that? We're going to take each individual element, the atomic mass of each element, times it by how many of that element we have, and we're going to add all those numbers together. So let's look at carbon first. How many atoms of carbon do we have here? We have 12. So I'm going to do 12 times the atomic mass of carbon. Now we look up here, the atomic mass of carbon is 12.01. So we're going to times that by 12.01. Now we're going to add that to the same information, but as it applies to hydrogen. So how many hydrogen atoms do we have? We have 22. So 22 times the atomic mass of hydrogen. So if we go back up to our periodic table and we take a look at it, we see the atomic mass for hydrogen is 1.01. So I'm going to plug that in here, 1.01. And finally, we're going to add that. I ran out of room, so I'm going to go down here. I'm going to add that to oxygen. So how many oxygen atoms do we have? We have 11. And we're going to multiply that by the atomic mass of oxygen. So going back to our periodic table, we'll look at oxygen, and that number rounded to 2 decimal places is 16.00. So I'm going to write 16.00. Now, if you put all of this into your calculator, you should get an atomic mass of, let's see, 342.34. And don't forget about the unit, AMU. Okay, so that's just step one, is just finding the weight of the whole, finding the weight of the whole molecule. Now I want to determine what percentage of carbon, hydrogen, and oxygen make up this entire molecule. So we're going to look at each one at a time. First, let's do mass percent of carbon. So do you remember the formula? So mass percent of carbon is how many carbon atoms there are, so in this case 12, times the molecular weight of carbon, which is 12.01, divided by the mass of the whole molecule, which is 342.34. And we're going to times this by 100. Now, if you put that into our calculator, we should get 42%, or something right around there. Now, let's do mass percent of hydrogen. How many hydrogen atoms do we have? We have 22. What's the atomic mass of hydrogen? We figure that out up here. Atomic mass of hydrogen is 1.01. And we're going to divide that by the mass of the whole molecule times 100. Now, if you put that into your calculator, you should get around 7%. Finally, we'll do mass percent of oxygen. So how many oxygen atoms do we have? We have 11. We're going to times that by the molecular weight of oxygen, which we figured out up here was 16.00. And we're going to divide that by the weight of the entire molecule, which is 342.34 times 100, and that is going to come out to 51%. So now if we look at these three numbers, what that's telling us is that in this C12H22O11 molecule, that 42% of that is made up of carbon, only 7% of it is made up of hydrogen, and 51% of it is made up of oxygen. Now, it's okay if, for example, you didn't round the percentage of hydrogen up to 7, if you kept it at 6.5. There is some margin of error when you figure these out. So what you can do to make sure that you're on the right track is if you add these numbers up, they should be really close to 100%. But depending on how you round, sometimes they might come out to like 98, 99, or even like 101, 102, a couple percentages over, and that's okay. But however, if you add up the percentages that you get and you're coming up with like 70-something% or 80-something%, then you need to double check your math and make sure you figured out everything correctly, because that's just too big of a margin of error there. So that's it. So that is how you figure out percent composition and molecular formula weight. So if you guys have any questions, please feel free to ask.